Hi everyone, my name is Firoz and I am a MTech CSC postgraduate in Triple IT Kota, and I have prior 2 years of work experience, 2.5 years of work experience prior before my MTech, and currently have completed my coursework uh, in the past 1 year, and currently I'm looking for an internship uh, in ML engineering and NLP domain. Whisper is a ASR automatic speech recognition model from OpenAI. This is one of the most it's the state of the art transcription model with the highest with the lowest word error rate, with the lowest highest accuracy, lowest word error rate, and this model has been trained uh, on one of the largest data sets. Why it's the state of the art model? Because it has been trained on more than 6 lakh 80,000 hours of training data, and it's trained uh, on more than 100 languages. Majority of the training has been done in English, but around 20% has been done on multilingual data. However, what makes this model unique is the way it has been trained. Since large amounts of data has been trained on this model, uh, the model has checkpoints to other low resource languages, so that with some extra fine tuning you can achieve high accuracy, very low word rate for other low resource languages like Telugu, Tamil, Kannada, Marathi, uh, which is specifically required for the Indian context. So talking a little bit more about the Whisper model. Whisper model basically underlying uses a transformer model. Transformer model consists of an encoder and decoder model, which was first uh, found in the Attention is All You Need paper. The main thing about this wisdom model is in the paper they have described that uh, the performance improvements is not because of the architecture, and it's because of the training uh, that has been done on this model. So that's why it's able to achieve such high accuracy and crossing all benchmarks. So in this assignment, what I have done is I have used the multilingual Whisper large V3 model. This is the biggest model, the biggest and the most recent model that has been published by OpenAI, and we have augmented an entire pipeline on top of the vanilla Whisper model. There are many layers. I have used a library called stable TS. It has been made uh, on top of Whisper model. This library, on top of this library, is another library called as faster Whisper. It underlying uses a CT translate 2, and this is one of the inference engine. Another alternative that is found to have uh, more accuracy than this pipeline. The current benchmarks in ASR is being led by this library. This library uses a phoneme model uh, at the end, after the transcript has been generated, to align uh, to align the transcript. In case I needed to improve the current pipeline, I go ahead and implement this phoneme model, which is based on the forced alignment word to vec. This paper was by Meta. Uh, this using this technique, they were able to uh, find more training, set uh, more training data for low resource languages. So this is the pipeline. Additionally, I have used some pre-processing techniques such as audio normalization, dynamic range compression, noise reduction, and Wiener filter. And I have use the Celora VID and Demux library. This is also from Meta, that that optimizes the audio before transcription, and custom prompting with respect to the downstream tasks such as translation, summarization, and question answering. So in order to run this notebook, we need to run this setup. I have accumulated this into one cell, and if you expand this, the entire functionality along with the uh, code has been detailed. Uh, uh, but if you run this, it will take around 5 minutes to set up the whole code. I have actually run this. Before running this, I would suggest to initialize the T4 GPU on which this project was built upon, and then I would go ahead and run this app. When I run this app phase, I have built this Gradio app to uh, to show all the functionalities of this one. I can just click here and go to the app, and here we can view the app. So this is the interface, and upload option is any audio video file can be uploaded from here, and you can upload an YouTube link also. Now if I go ahead and upload a file, it will take a couple of seconds to upload, and then I will state the language in which the audio which has been spoken in, right? And I'll also state how, like, up to how many speakers, different speakers can there be in this audio file. And if I click on transcribe, it will take a couple of minutes, around 2 to 3 minutes for the transcription process. Uh, until then, I will go ahead and I'll show you the logs of what is being done behind the scenes. So if you see the logs here, first the resampling was done. Resampling, in a sense, we have to uh, uh, since Whisper models takes a 16 kilohertz sampling rate and a 16-bit depth audio file, we have to first uh, any audio file needs to be converted into that format, and then we have to normalize the audio file and applying Wiener filter. Initially we'll do all the audio processing steps, and then we'll load the Whisper model. We'll load the Whisper model. uh, uh, Here the Whisper V3 model is being loaded, and right now, as you can see, the DMX is being used to isolate the voice activity in the audio and then detected language. Whisper also does a auto detection. What it does is it uses the first 30 seconds of the audio file and find which language is being spoken in the first 30 seconds, and then transcription is being done. Uh, this is the current transcription process. Here, voice activity detection is being done, and immediately after activity detection, we will start with speaker diarization. Speaker diarization is a step where we detect the number of speakers, where we detect the different speakers and at what timestamps did they speak. Uh, we first load the models, and then we do segmentation, speaker counting, embeddings, and this one. And after that, the transcription is complete. If we go back to the app, we can see the transcription of the audio file. And afterwards, we can just click on the language to transcribe. If I select Hindi, uh, and if I select translate, uh, and if I go to the translate part, and this is being translated. Underlying it's calling the Gemini API. Gemini API to do the translation. It is sending the transcript along with some prompt. This is the transcript. Similarly, summarization can be done in any of the languages. So this is the summarization in the. So going into the code, I'll stop the app for now. And going into the code, uh, we'll first install all the libraries. There are tons of libraries that was used to implement the code, and then we'll go to I have designed some utility functions that will be used by many of these functions below. This is the function in which the entire functionality to download audios and videos file from YouTube, and this is the resampling, in a sense, where we convert the audio file into 16,000 kilohertz sampling rate and a bits sample depth of 16, and this the underlying code uses torch audio, and this is the converter where any audio or input file has been like audio uploaded, any audio video file uploaded by the user uh, is handled by this function, and we are using ffmpeg to do the conversion task. Um, and then this is the code to do some audio pre-processing techniques, and the code for the pre-processing techniques is described, is detailed here. This is the main transcriptor class. This is the configuration file for the transcription process. Unlike Whisper model, we are using a load faster Whisper from the stable Whisper library. So we are doing, and this is a function to clear the CPU and GPU memory, and this is the pipeline to do speaker diarization, where we segment the speakers, and this is a script that I use to post process the transcript, where we are segmenting the words separately with respect to each speaker, which word, and then uh, we are segmenting with respect to speakers, uh, where all the speakers are made into a single chunk. uh, and then this is the generative AI LLM class, downstream analytical prompts. uh, this is the wrapper. uh, the main the concept behind the code is, for any audio file, uh, we wrap a semantic wrapper around it, and we pass this to all the functions. Since Python takes any value by reference, we'll pass everything through pass by reference, so that I can, keep all the different functionalities as independent as possible, uh, to help in debugging, and to help in case any modifications that's required, or any other functionality that's been required, and I'll just pass after each other through a pipeline. So the idea behind this semantic wrapper was this, and this is the demo pipeline. uh, this is the pipeline where all the functionalities will be processed one by one, and this is the code to uh, connect the Gradio app with the entire pipeline. And if you click on this, we will get uh, uh, the app launched here. uh, I did the evaluation on this pipeline, and we got a uh, uh, since evaluation takes a lot of the evaluation data sets are huge. The minimum evaluation data set was 1 GB data set, and to uh, uh, to compute a benchmark wouldn't be possible with the available GPU compute power. So I evaluated this model on a YouTube video. Uh, this is a All India Radio Service YouTube channel, and a gold transcript. This is the voice audio file and the gold transcript, and I generated the transcript from this model and compared it with the gold transcript, which was available in the website, and I found CER blue error rate to be very low. uh, this is because the this the spoken data, the speech data was completely read out of this transcript. So uh, so we would expect this would not represent a real world simulation of a speech recognition model. because in case of a natural language speech, uh, the sentences are not complete, and there are so many disturbances between the speech itself. But evaluation, I think it's done a pretty good job of evaluating uh, uh, the ASR. That's it. Thank you.